Hello class, this is the video for Appendix E that talks about sigma notations. So in this video, we'll understand what the sigma notation means. It's basically the sum, and apply the rules of sigma notation to simplify problems, okay, or evaluate sigma summations. All right, so here's a definition that assuming you have this sequence, okay, or these numbers, am plus 1, am plus 2 to an. These are real numbers, and then m and n are integers such that your m is less than or equal to what n. Then when you write, this is the sigma, okay, that's a sigma notation, meaning the sum, okay, you're summing over a certain interval. Okay, so this is taken from I, it's a dummy variable, starting from m to n of ai. So when I is equal to m, you have what? am. If I is equal to m plus 1, then you have the second term, then plus the third one, plus the fourth, all the way to n, and then you add all of them together. So this notation means what? It means what? Sum. Okay, that's what I say, sigma notation. So if we use in terms of functions, not just the real numbers, then we can have this definition that we evaluate the function at what? M, at m plus 1, at m plus 2, all the way to n, and then we add all of them together because of the symbol sigma. Okay, so let's write a sum, this in the expanded form. Okay, this is the sum, the function is what? The square root of I. Okay, I could use square root of x, and then x will start from 1 to 5. So this means that we evaluate it at what? X is equal to 1 plus square root of 2 plus square root of 3 plus square root of 4, and then plus square root of 5, because it goes up to what? Up to 5. Okay, and in this case, the 1, okay, we'll consider m is the lower limit, and then your n is the what? The upper limit. Okay, lower limit and upper limit. Okay, now let's evaluate the second one. The lower limit is k from 0 to what? To 4. If k from 0, you have 4. The first, when k is equal to 0, that's the 2 times 0 minus 1 divided by 2 times 0 plus 1. Okay, then plus 2 times 1 minus 1 over 2 times 1 plus 1. That is the k is equal to 1. And k equals to 2 will be 2 times 2 minus 1 over 2 times 2 plus 1. Now k equal to 3, you have 2 times 3 minus 1 over 2 times 3 plus 1. And then k is equal to 4, you have 2 times 4 minus 1 over 2 times 4 plus what? Plus 1. Now if you simplify this, you're going to be what? Minus 1 over 1 plus what? 1 over 3 plus that's 1 over 3. Okay, and then if you simplify it, you have what? 3 over what? 3 over 4. Sorry, 3 over 5 plus the next one 6. That is what? 5 over 7 plus what? 7 over 9. Okay, so we have this. Then we can simplify this to get the actual value, but it's just right in the expanded form, so we don't do much after this. Don't do anything else after that. Okay, now this is another definition. If c is a constant, all right, and then you are adding a same number, n number of times, it is basically what? N times what? N times the constant that you're adding. Okay, so For example, if I'm adding, this is the sum from 1 to 5 of what? The number constant 3. So I'm adding 3 from 1 to what? 5. That's 5 times. 1, 2, 3, 4, 5. So it'd be 3 plus 3 plus 3 plus 3 plus 3, which is the same as what? The n, 5 times what? The constant, which is 15. And that is for that definition. Okay, now here's another example. Say, write the sum in a sigma notation. In a sigma notation. Okay, so we're going to have, well, this is going to be sigma, right? We write a sigma, then I from what? If you say I from 1, I from 2, I from 3. So let's say the simplest one will be I from 1. Okay, then we have, this is adding what? 1, 2, 3, 4, 5, 6, 7. So it's going to be just I, because we want the I, because when I is 1, you get 1, I is 2, you get 2. And we are adding this up to what? Up to 10. Okay, and that is one of the possibilities. So let me write it here. You have what? Z sigma from 1 to what? To 10 of what? I. Now I can let this start from either 2 or 1 or 0. So if you let this start from 2, for example, so they get I equal to 2. Somebody can write it the same way. Well, if I'm adding 2, then I need to get 1. Then the first term here should be 1, should be like 2 minus 1. So what we do is that we're going to write what? I minus 1. Okay, I minus 1. Let's see, that would generate 1, 2, 3, 4, 5. When I is 2, you get 2 minus 1, which is 1. If then you go to 3, that will be 3 minus 1, that gives me 2. 3 minus, okay. So then what would be the last one to get 10? See that if you put 10 here, then you have 10 minus 1, which is 9. That gives me just 9. It doesn't give me the last term. So it means that this must be what? 11. So that you do 11 minus 1, you get what? You get a 10. So what is happening is that if this is the I is a dummy variable, right? An arbitrary number, dummy variable. If you increase, okay, if you add 1, then the operator, you subtract 1, and then you add 1 to what? If you add 1 to this, the lower limit, you add 1 to the upper limit. So this answer, let me write it well. It will be the sigma from I equal to 1 to what? I minus 1. Okay, I could have used K, doesn't matter. Or this same thing, if I start from 0, okay, let's see. If I start from 0, then the first term must be 1. If I is what? 0, it doesn't give me 1. So it means that to get 1, I need to add what? 1 to that. So if I is 0, I get 0 plus 1, which is 1. If I is 1, the next one is 1 plus 1, which is 2, like that. Well, what would be the upper limit? Okay, you see that is going to be what? 10 minus 1, that is 9. So that I get 9 plus 1, which will give me the last term there, which is 10. Okay, so all these possibilities are the same. Okay, I could have written it this way, or that way, or that way. Okay, well, let's go to the next one. Now we're going to have for our sigma, I'm going to use k equal to certain value. Okay, let's start from say 1, right? Let's start from 1. K is equal to 1. Now, what you see here, this is a fraction. Okay, if it is 1, to get 1 in the numerator, and then the denominator is what? So if what is happening in the numerator, to get the denominator, you add 1 to the numerator. So the denominator is what? 1 plus 1. It's 1 plus 1. Here, it'll be 2 plus 1. That gives me the 3. Okay, and then when I is equal to 3, you get 3, and this will be 3 plus 1, and that would be 4 plus 1 in that order. This is 19. 20 is 19 plus 1. So what happens is that the numerator will be I. Sorry, this I'm using K. Then this will be what? K plus 1. Okay, and it goes from what to what? Okay, it starts from what? 1 to 19. So that goes up to what? Up to 19. Okay, now if I decrease this to, let the k start from what, 0. Okay, then the numerator will be what? K, all right, plus 1. The denominator will be what? K plus 1, then plus 1. And then the numerator, because I reduce it, this is going to be what? It should be what? 18. Okay, so that I get 18 plus 1 is 19. Or, so if you simplify that, that is give me 18, and then k from 0, you get k plus 1 over k plus 1 plus 1, which is what? K plus what? Plus 2. Okay, so this is also work, will generate this what? This sum easily, as well as that is also correct. Okay, all right, now there's a theorem, okay, with two theorems basically that we want to look at. Theorem number 2, if C is any constant, that is it doesn't depend on I or the dummy variable, then the following are true. The constant multiple, so if I'm adding I from M toward N, then of the expression C times AI, I can bring the C out because the C doesn't depend on the dummy variable I, and then that gives me times that. All right, the second one is that if you have the sum of two things, then you can distribute the sigma, the sum, the sigma notation over that. So if I have this, I can write this as what the sum I from M to N of A plus the sum from M to N of B. Okay, the same applies to the difference. If it is minus, then we can write it like that. Okay, so we have the first one, you add all, then you subtract what? The second. All right, so let's take an example. So if I'm adding K, I'm adding what? 3K. K started from 1 to what? To 5. Okay, since the 3 is a constant, doesn't depend on K, we can bring it out and write this as what? 3 times what? The sum up to 5, and then what? K from 1, and then I get K. All right, so this is the symmetry, and then from 1 to 5, I get K is equal to 1 is 1. K is equal to 2, that will be 2, plus 3, plus 4, and plus what? Plus 5. Okay, so if you put this together, this is what? 3 times. If you add this is 15. And so that gives me what? 45. So that's the value. Now let's look at the second one is a sum. So I can spread it as what? From I equal from 1, and I have what? I squared, then minus the sum up to 3 of what? The constant 2. Now what would that give me? If I add this from 1, the first one, I have, it will be what? 1 squared plus 2 squared plus 3 squared. The minus, this is a constant, I'm adding it 3 times. That's the same as 2 times what? The 3, because that's my n. Okay, so if you simplify this, will be 1 plus what? 4 plus 9 minus 6. And that gives me, you what? Is it 8? Okay, you have 5 plus 9 is what do you call it? It's 13. 13 minus that 5 minus 9 is 14 minus that is it's going to be 8. That's correct. Now let's do the same thing for a difference. This will be the I. Okay. I squared, then minus the sum I from 1 to what? To I. Okay, so let's do that. This will be 1 squared plus 2 squared plus 3 squared, then minus, that'll be 1 plus 2 plus 3. All right, so you have just like 1 plus 4 plus 9 minus what? Minus 6. And that also gives me what? 8. Okay. All right. So it's by coincidence they are both 8. All right. Because this is 14 minus that will be 8. All right. Okay. Then there's a third theorem, right? And it says that the following theorem gives formulas for sum of positive integers needed to for finding, okay, areas under curves and evaluating integrals in chapter 5. Okay, so the following are very important. If you forget anything here when we get chapter 5, especially 5.1 and 5.2, where we're going to use this a lot. Okay, so let's C be a constant. Okay, any constant, and n is a positive integer. Then the following are true. Okay, the first one is that if I'm adding, now notice that I'm adding from what 1 to n we don't know. Okay, it could be 10 or 20 or whatever, and now I'm adding the same number, the number 1 n times. This is the same as what n times 1, which is just give me what, just give me n. Now we also talked about this before. If I'm adding from I taken from 1 to n of this constant is same as the constant times what? The number of times that I'm adding that. Okay. Now, here comes the sum of the first n positive integers. So that means that if I have this 1 plus 2 plus 3 plus 4 all the way, this is plus a certain number n. The sum of first positive integers. If you simplify this, the sum you will get is to equal what? N times n plus 1 divided by 2. Okay, then you must know the number of times what your n is. Now notice that this applies only when what? X starts from 1. So if you have something like that, I start from 1. If you start from 0, okay, to say n, then you need to rewrite this to start from 1. Okay, in some textbooks they start from 0, and there's a formula for that. Okay, so don't forget, if we start from 0, then we have to rewrite whatever is there. So if it's be I squared, then if you start from 1, okay, if you start from 1, we are adding, okay, you are adding 1, so that means that we're going to what? You're going to subtract, okay, you're going to be I minus 1 all squared. So that if it's 1, you get 1 minus 1, get 0. So the first term number will be what? 0. And then when it happens, this will be n plus what? N plus 1. So take note of that. Okay. That is we're going to prove this part. I'm going to prove this part. Then the D, the sum of the first n squares. So we have something like 1 squared plus 2 squared plus 3 squared all the way to what? N squared. It is given by the what? This formula. Okay, that is n times n plus 1 times 2n plus 1 all divided by what? 6. Like I said, I'm going to prove this, and later you can try this D. And then the last one is the sum of the first n cubes. So this is 1 cube plus 2 cube plus 3 cube, okay, to what? N cube. And that is equal to what? This formula right here. Okay, now don't forget, we're going to use this to find what? Area under curves, and then evaluating what? Integrals in chapter 5. So you cannot forget these 5 what? Formulas. All right. Now, let us prove this. We're going to use what we call Gauss approach. Now, this guy is a great mathematician and physicist. All right. When he was in about 5th grade, very young, his teacher asked the whole class, there's a story behind this, asked the whole class to add the numbers from positive number from 1 to 100. And he thought that they're going to take a while so that he can focus on something else. And then before he knew, without no distant time, then Gauss gave the answer. then this is his approach. So we're going to write the sum of the first n terms. We're going to denote this by what? S. And then will be 1 plus 2 plus 3 plus 4 plus what? All the numbers. The next one will be n minus 1. And then this is what? The last one will be n. Then we're going to write this in the reverse. Okay? We're going to still S, but in the reverse order. This is n plus n minus 1, n minus 2, plus n minus what? 3. Okay, let's put all this in 1 so that you know that. Then plus, now this will be what? This will be 2, and this will be 1. So then he decided to add them. Okay, find a sum. So we have s plus s, he gave me what? 2s. Okay, 1 plus n is what? N plus 1. And then 2 plus n minus 1. So that also give me what? N plus 1. Then 3 plus n minus 2 also give me n plus 1. Okay, 4 plus n minus 3 is what? N plus 1. Okay, now if you continue, n minus 1 plus 2 is what? N plus 1. Okay, and then plus finally n plus 1. Okay, now how many times? This is what? N number of what? Times of what? N plus 1. So we are adding n plus 1 what? N number of times. Now if you do that, then this is the same as, it's just like you have a constant. We have number what? 3 plus 3 plus 3. If you add it what? 10 times, is the same as 3 times 10. So then this will be n times n plus what? 1. And then you have 2s. Now you are finding the sum, divide both sides by 2. Okay, then you have for the sum is equal to what? N plus 1 times n over what? 2. Okay, so that is why the sum, if I add the sum from 1 to what? N, it is of i's, okay, is equal to what? N times n plus 1 over what? Over 2. Okay, so that proves the what? That proves this formula right here. All right, now let's take some examples. Exercise number 21. It said applies theorem 2 and 3. Some will apply the theorem 2, others will apply the theorem 3. Right now, let's look at it. We are adding this expression as a matter of f of I is what? 3i minus 2. Okay, and I'm adding from 4 to what? To 8. It doesn't start from 1, it doesn't start from, so I can just go ahead and just start from when I is equal to 4. I have the first one will be what? 3 times 4 minus 2. That is the first term. When I is go to the next number, which is what? 5, will be 3 times 5 minus 2. Then plus 3 times 6 minus 2 plus 3 times 7 minus 2. Then finally 3 times 8 minus 2. Okay, so let's simplify everything there. If we do our calculations correctly, that will give us, this will be 10 plus 13 plus 16, okay, then plus 19 plus 22, okay, so you get 24 minus 2 is 22. Now we add everything there, that gives me what? 80. All right, so this is very simple. And but the thing is that if I want to use the what do you call it, the theorem 3, I can use that. All right, but I'll show that to you in class how we're gonna go about this. So let's take another example, different example. Okay, exercise number 27. That also start from what? 0, as you can see, right? So this is going to be, we can do this. You can do it like this, just like I from 0 to 4 of 2I, then plus, we do the same thing from 4, from 0 to what, to 4 of what, I squared. All right, so this basically means that I should find a sum when I is from 0 to 4 of 2 to the what, I. So that gives me, 2 to the 0 plus 2 to 1 plus 2 to the second power plus 2 to the third plus 2 to the fourth. Then plus, okay, you have 0 squared plus 1 squared plus 2 squared plus 3 squared plus 4 squared. Now, if we add this will be what, 1 plus 2 plus 4 plus 8 plus 16. Then plus, this is 0 plus 1 plus 4 plus 9 plus 16. Okay, so when we add everything there, this will give us I'll give us a 61. So if we add everything, this is going to be this side will be 30, I believe it's 31 plus what, 30, and that gives us 61. Okay, all right. Now the last one we'll deal with. See that it started from 1, I from 1 to what, to that. The first two we use what, theorem 2 for that one. That also, the other one, 2, we use the word theorem what? Theorem 2. All right. So the next one, 3, we want to use theorem 3. The theorem 3. Well, we are given this, the sum I from 1 to what, n of I plus 1 times I plus what, 2. We will distribute that, we will multiply that out. This is give me the sum to n. This, if you multiply this out, to FOIL that, that is what, I squared plus 2I plus I, then plus what, plus 2, which will give me the sum, okay, I squared plus 3I, then plus what, plus 2. Okay, so when we do that, we simplify that, we distribute the sigma notation over this. So that should be what's the sigma of I squared plus the sigma of 3I, then plus the sum of 2n. Okay, so what will that give us? Okay, this will give us what, the sum, and then it's I squared. That should be 3 times that, 3 times the sum from 1 to n, then plus what? This is just, let me repeat that. The sum from 1 to n of what? Of 2. Then if I use the theorem 3, remember this is given by what? N times n plus 1 times 2n plus 1 divided by 6. Okay, the second term here will be the sum from the I. It will be 3 times, it is n times n plus 1 over what? Over 2. Over 2, then plus, this will be what will be 2n. Okay, so we can simplify this all together. This is over 2. Let's simplify that. If you simplify or distribute them, okay, you have the denominator, this will be what? This will be 6. Let's keep the n, and for the other one, this will be n squared. Sorry, 2n squared plus n plus 2n plus 1, then plus Okay, this is 3n squared plus what, n, all over 2, then plus what, 2n. Okay, and then when we simplify that, this part, this will give me n, okay, 2n squared plus 3n plus 1, then plus, let's keep the 3 outside, n squared plus n all over 2. This is all over 6 plus what, 2n. Then if the LCD is what, is 6, okay, to multiply the numerator by this, the first term will be the same. We'll keep it as n, 2n squared plus 3n plus 1. And the second term will be, this is that everything is going to be divided by 6 anyway. All right, divided by 6. So that's going to be 9. 3 times 3 is 9, n squared plus n. And then this is going to be 6 times 2, which is what, 12n. Okay, and then when we simplify everything there, it will come to n cubed, all right, plus 6n squared, okay, plus 11n, all divided by 3, which you can write it as you factor n out, n over 3, and everything. This will be n squared plus, what do you call it, 6n, then plus what, 11. Okay, so that will be the final answer using the theorem 3. And I will show you in class doing other examples. This is the end, and I hope this is helpful. Thank you. Bye-bye.